All right, let's dive in. Today, we're going to do something a little different. We're actually going to step into the shoes of a red teamer and see step by step how they map out and, ultimately compromise a Google Cloud environment. And that's exactly what we're talking about, right? An attack on a cloud environment isn't just random smashing and grabbing. No, it's a strategic conquest. And to conquer a kingdom, you first have to understand the layout of the land. So, where do we even start? Well, that brings us to stage one, understanding the terrain. Before a single line of malicious code is run, an attacker needs to know the fundamental structure of this Google Cloud battlefield. And you've got to understand how these three big pieces fit together. You've got cloud identity, that's the gatekeeper. It manages who you are. Then there's Google Workspace. That's how you collaborate. Think Gmail, Docs, all that stuff. And finally, the Google Cloud Platform, GCP, which is the land itself, right? It's where you build everything. An attacker has to navigate all three. Now, GCP isn't just a flat open field. It's a really strict top-down hierarchy. You've got the organization at the very top, then you have folders, maybe for different teams. Inside those, you have projects for specific apps. And at the very bottom, you have the actual resources, the virtual machines, the databases, you name it. And here's the kicker. Permissions flow downhill. If you can control the top, you own everything underneath it. And this is the rulebook for the entire kingdom. Identity and Access Management, or IAM. Now, what's really important here is that in GCP, you attach the rules to the resource, not the person. Think about it like this. Instead of giving someone a key that opens a bunch of doors, you put a list on each door that says exactly who can open it. And for an attacker, figuring that out, that's game-changing. Okay, so the attackers got the lay of the land. They understand the rules. What's next? Well, their main goal becomes crystal clear. They need to find the keys to the kingdom. They have to get their hands on some credentials. In Google Cloud, there are basically two types of keys they're looking for. You've got your standard user accounts for people, right? Username and password. But the real prize, the thing attackers are really after, is a service account. These are for applications, for non-human users, and they use a downloadable file, a JSON key, to authenticate. If you find one of those, you can start automating your whole attack. And this really gets to the heart of how attackers think. They don't need the master key right away. They just need one key. Any key. Anything to get inside that first door. Even an account that can barely do anything is still a foothold. And from there, the real fun begins. So with that first key in hand, a smart attacker doesn't just start breaking stuff. Nope, they start looking around. This is the reconnaissance phase. It's all about quietly mapping the environment from their new privileged position. The very first thing they're going to ask is, okay, where am I and what can I see from here? They'll run a simple command, something like gcloud projects list, just to see all the different projects, all the different territories that their key gives them visibility into. Okay, cool. Now what's next? Well, the next logical question is, who else is in here with me? So they'll start listing out all the other service accounts in any project they can see. Every single one of those is a potential next step, a more powerful key that they could try to steal. And then they go for the rulebook itself. They'll pull the IAM policy for the project. This is huge. It tells them exactly what their current account can do, and more importantly, what every other account in that project is allowed to do. They're just hunting for a weakness, for one door that someone accidentally left unlocked. And once they find that weakness, that's when the mission changes. It goes from quiet recon to an active attack. It is time to use all that info to start climbing the privilege ladder. And the attack itself, it's really just a simple, repeatable loop. You start with an initial compromise. From there, you enumerate and discover the environment. Once you find a weakness, you exploit it to grab a better key. And then you escalate your privileges. And with that new power, you just start the cycle all over again, digging deeper and deeper. Okay, so let's paint a picture here. This is a classic. An attacker finds a vulnerability in a public website. That website's running on a virtual machine in GCP, and that VM has a service account attached so it can do its job. By exploiting the website, the attacker gets access to that service account. Boom, they have their initial foothold. Now they start looking around, poking their head into different rooms. They can't do much with this account, but they can get a list of storage buckets. And one of them, DevOps Storage Metatech, well, that sounds pretty juicy, doesn't it? DevOps tools often need really powerful credentials. And this right here, is the jackpot moment. The attacker checks if their key can read from that bucket. Turns out, it can. And inside, they find exactly what they were hoping for, another service account key file just sitting there. They immediately copy it right down to their own machine. And bingo, they activate that new key, check its permissions, and just as they thought, this new DevOps service account is way more powerful. Maybe it can create new virtual machines, maybe it can even change the IAM policies itself. They've done it. They have successfully escalated their privileges and now have a much, much stronger grip on the environment. Okay, so seeing this whole attack play out is, honestly, it's incredibly valuable. Not for the attackers, but for us, for the defenders. Because by understanding the exact path they take, we can learn precisely where we need to build our walls and set our traps. So how do we defend our own kingdom? Well, first, we apply the principle of least privilege. That initial account in our story, it should never have had permission to read that DevOps bucket. Second, and this seems obvious, but never store sensitive keys in unsecured storage. That's like leaving your front door key under the mat. Third, you've got to harden your public-facing apps to prevent that initial breach. Fourth, you monitor for the exact kind of enumeration we just saw. And finally, you have to regularly audit your IAM roles to make sure no one left a door unlocked by accident. Look, at the end of the day, understanding the attacker's journey from the outside in gives us the blueprint we need to build our defenses from the inside out. We've seen exactly how they get in, step by step. So the only real question left is, have you checked your front door? Thanks for joining me.